Okay, so today I want to talk about this concept known as the top-down design. It is not a revolutionary concept. You most likely have seen it before. Just in computer science, we like to systematically sort of label things and get things down to a kind of very step-by-step process. So that's what we're going to look at today, is this idea of the top-down design. As soon as this actually starts working. Oh, that's why it's frozen. Okay, so relating to our discussion on problem solving, we're going to slip this in as a model, right? Remember we talked about the idea of models being things that you can use to help work through problems. So one of the models we're going to use is this idea of the top-down design. Now again, it's not revolutionary, but you're going to find that this does appear in the profession of computer science. It is used very often. You're not going to find you're going to use it that much this year, generally, because your problems aren't going to be necessarily large enough. But I do find that, for example, some of my grade 12 students do this as a technique in larger programming activities, okay? It's a very simple concept. Take a problem and break it into smaller problems, okay? And then do that again, each part individually. Okay. It works well with problem solving because it allows you to start with a very general problem and then elaborate on it each step down, okay? Now the idea of a step you're going to see visually appear here, okay? The idea from the top down is again the way it's drawn, so you'll see that. It's also called, it also has other names. Some of them are stepwise refinement is one of the other names, a little more fancy. But let's just try it, okay? Here's a problem, and this is not a computer science problem, but let's just write this out as a problem. I want to build a barn. Okay, I mean, we do live in a rural community, so let's make a barn. It's a pretty big project, right? This is the idea that we usually visualize with the barn. So to actually build that thing is the problem that we can break into smaller problems. So if that's our top level problem, let's start by breaking it into 3 smaller problems. So we'd have to build the foundation for the barn, we'd have to build the walls for the farm, and then we'd have to put the roof on the barn. Did I say farm? I meant barn, okay? So that's as simple as the top-down is. But then from each of those lower steps, we continue the process. So from these 3 initial steps, in the next step down, we focus just on this now as the only problem. To build a foundation, I have to dig and then pour concrete. Notice when I focus here, I just focus on that step. I don't worry about the other steps of the problem. Similarly, when I go in to build the walls, I focus just on that step. And I frame the walls, and then I put up the paneling. Similarly, when I build the roof, I focus on the 2 aspects of that. And 2 aspects is just a generic. I don't have to necessarily make it 2. I could have made it 1 or 0 or however many I want, okay? I could continue this process. I could break up digging into specific steps. But I think you get the idea here. What we have is we start with a very general problem and we result in lots of little problems, okay? So that's the whole idea, is take your big problem and turn it into lots, so you get more problems, but each of the little ones are simpler. By completing the little ones, you complete the step above and then eventually complete the whole thing. Okay? Combine this together with what we've sort of did in the last part. Let's roll it together. How many different ways, and I think this is related to the fact that we're right before lunch. How many ways can you cut a square sandwich into equal parts? Now, let's think about that for a minute. I know, like, I made a sandwich for my daughter last night, and she likes it cut on the whole diagonal. Or do your parents like to cut it right down the middle? I'm a big diagonal fan because it gets that sharp edge that you can shove in your mouth a lot easier. How many of you are diagonal sandwich cutter fans? Just wondering, are you guys all the traditional, just right down the middle? Yeah. Most of you don't care, right? You don't care what I'm talking about right now. But is there other ways? Could we cut it so that if you share your sandwich with somebody, you both get the same amount of sandwich? We got 2 ways right now. Maybe there's more. So step 1, what's the problem? Okay, well, it's pretty well defined. We just talked about it. We got to get the sandwich cut in half. So now we could use the top-down model as a way to break up the problem, right? So cutting the sandwich is the initial problem. I could use a common, very simple 1 cut. I could use variations on the 1 cut. I could use more than 1 cut. I could make a really odd-shaped sandwich. Let's break those up, okay? I could go on the diagonal or I could go on the rectangular cut. I could go a little bit off the center, right? I could use a diamond shape or a square and a square or a hexagon shape or maybe some weird L-shaped sandwich. It's just, again, brainstorming and modeling out the solution. Now, I did this one just for fun because I like to torture grade 10s right before lunch. All you're thinking about is sandwiches. So then you analyze that model. Okay, so let's take a look. Here's some of the sandwich ideas. This is something you can play with tomorrow if you decide to make your own sandwich. See, these are the first two. These are the traditional. I'm a fan of this one. This one, not so much. But you could shift that off the center. You could go with something like this. That would be kind of cool. And then some of these other ones down here, even the L or the zigzag shape, who knows, right? Life is a variety. Spice it up a little, kids, right? Cut your sandwiches a different way. You'll be the talk of the cafeteria table. All right. Obviously, you'd check it over you'd measure the pieces. You know that old style, right? When you have a piece of cake left and you and your buddy want the same amount of cake, what's the rule? Yeah. And then you have no buddy, right? So now you've solved one problem but created another one. No, the idea is one person cuts it and the other one gets first choice, right? That keeps it fair. Right? All right. So again, that was a little bit of fun, but it's this idea of taking the problem and breaking it into smaller problems. Now, if we think of this in a computer setting, the computer really does, as we've said before, three things. It takes input from you, produces output, and then does something in the middle with that input to produce. I mean, that's a video game right there, right? You give it input in the case of keyboard presses, mouse clicks, joystick movements. It's going to provide output in the form of visuals on your screen, sounds through the speakers. It's the middle part, obviously, that's a big part of it. So we can put this into computing as well. It's also known as a hierarchy chart. Okay? Hierarchy just essentially means like top down. You may know another form of that word, monarchy, right? Like king, queens, princes, right? It's that idea again of moving from the top down. Okay. Now, top-down charts are not flow charts, okay? They don't generally deal with direction other than they go from the top down. We're going to look at what a flow chart is in this context. It's more specific, but hierarchy charts or top-down charts talk about basically the tasks to accomplish, not the sort of method of accomplishing it, okay? Basically, it just flows down. Okay, let's try another example. Making an ATM machine, okay? Now, I'm talking about the physical building of it, okay? So an ATM machine has inputs, it has outputs, and in the middle, obviously ATM or a bank machine does calculations, right? It does something in that particular area. So that would be our first level, right, is the basic input, process, output of an ATM. Second level, when we're dealing with inputs, if you think about a bank machine, you have to enter your PIN number or your password. You have to determine, am I taking money out or putting money in? And how much? Okay, that's my inputs. The outputs, well, with a bank machine, you're going to get money, okay? It'll give you a slip, and it possibly could give you an error message if, say, you put in the wrong PIN number, or I know if I tried to withdraw $1 million, it would certainly give me an error as I tried to withdraw that, right? So that's your outputs. The middle part would be a little more distinct. With the process of an ATM machine, it's really broken up into two parts. Deposits, withdrawals, okay? Deposits are easy. You just add that money to your balance. With withdrawals, you have to make a check. Like I said before, if you can't withdraw that much money, then if you can, you subtract it from the balance. If not, maybe an error message. Let's put it all together. This would be a top-down chart for an ATM machine, okay? Broken up into lots of little parts. So now this big problem becomes lots of little problems at the bottom levels. And again, the way you draw it, there's no real set rule on this. It's just a way to take problems and model them out in a way that kind of helps you to get a better grip on all the stuff you have to do. Okay, and that's all it is. All an ATM, all a top-down chart is a model for problem solving that helps you work through it. Okay? It's the divide and conquer method. Okay? Take the big problem and chop it into lots of little problems. And that's all I have for that, except for that crappy sound effect. All right? Now, with this, as I said, a short presentation,